Did you know that in just 1 year, over 1,500 major data breaches were reported? And the most shocking part? 80% of those digital break-ins happened because of stolen passwords or compromised login details. We often think, my password is super strong, I'm safe. We believe that complex string of characters is our digital fortress, impenetrable to any cyber villain out there. But what if I told you that your strong password is only half the story? What we really need to understand is the silent, unsung hero working behind the scenes. This hero is the backend, and it's the real reason your account stays safe, even when hackers are trying everything they can. Let's peel back the layers and discover the powerful mechanisms that stand between your sensitive data and those with malicious intent. This isn't just about what you type, it's about what happens after you hit enter. Let's start at the beginning, what we actually see. Imagine you're trying to get into an exclusive club. You walk up to the velvet rope, tell the bouncer your name, and show them your ID. That's a lot like logging into an app or website. You, the user, are at the entrance, typing your username and password into the front end, the part of the application you can actually see and interact with. And here's where it gets interesting. Once you hit that login button, your browser or app takes those credentials, your digital name and ID, and bundles them up. It's like putting them into a secure envelope and sending them off on a journey. This journey isn't to another screen on your device, it's across the internet to a powerful computer far away, known as the server. This server is where the backend lives, silently waiting for your request. It's the club manager, in a secure office, ready to check your details. What we need to remember is that this first step is just transmitting the information. The real work, the actual verification, hasn't even begun yet. Your credentials are just knocking on the door, waiting for someone to answer and check them against the guest list. But the genius part is this. Once your login attempt reaches the server, the backend springs into action. This is where authentication happens. Think of it like this, the server isn't just looking at your ID, it's comparing your face to a photograph on a secure database, confirming you are who you say you are. The backend takes your username and searches its database for a matching record. If it finds one, it then looks at the password you provided. Now, this is crucial, the server doesn't store your actual password in plain text. That would be like the club manager writing everyone's secret PIN on a whiteboard for all to see. Instead, it stores a special, scrambled version of your password called a hash. When you send your password, the backend immediately scrambles your provided password using the exact same secret formula it used when you first signed up. Then, it compares this newly scrambled version with the stored, scrambled version. If those two scrambled strings match perfectly, congratulations! The backend confirms your identity, and you're authenticated. If they don't match, access denied. This hashing process is a one-way street, making it incredibly difficult for anyone to reverse engineer your original password, even if they somehow manage to steal the database. It's like knowing the ingredients for a cake, but not being able to magically unbake it into individual eggs and flour. So, we've talked about hashing, that one-way scrambling of your password. But how does that differ from encryption, a term we hear just as often in security? Let's use another analogy. Hashing is like taking a giant block of ice and smashing it into tiny, identical pieces of snow. You can easily create the snow from the ice, but you can't magically put the snow back together to perfectly reconstruct the original block of ice. The information is fundamentally transformed, not just hidden. Encryption, on the other hand, is like putting that block of ice into a special, locked freezer. Anyone can see the freezer, but only someone with the right key can open it, take out the ice, and put it back in. The data is reversible. It's transformed into a secret code, but it can be decoded with the correct key. This is what protects your data as it travels across the internet, like when you connect to a website using HTTPS. Your password is encrypted before it leaves your device, and only the server with the correct key can decrypt it. The backend uses both. Hashing protects your password when it's stored in the database, making it useless to a hacker even if they steal the database itself. Encryption protects your data, including your password, while it's traveling between your device and the server. Together, they form an almost impenetrable fortress for your login credentials. And here's where we add an extra layer of defense, like putting a second, totally different lock on that vault door, multi-factor authentication, or MFA. You've probably used it. It's when an app asks for more than just your password. After you successfully enter your password, the backend sends a unique code to your phone, or asks for your fingerprint, or uses a special app to generate a temporary code. This significantly boosts security because even if a hacker somehow gets your password, maybe through a phishing attack or by guessing it, they still need that second factor. They need to physically have your phone, or somehow trick a biometric scanner. The backend isn't just checking, do you know the password? It's checking, do you know the password and do you have this other thing that proves you're you? Once you're authenticated with all these factors, the backend doesn't make you repeat the whole song and dance every time you click a new page. Instead, it issues you a special, temporary pass called a session token. Think of it as a wristband at a concert. You've proven you paid, and now the bouncer just checks your wristband quickly. This token tells the backend that you're a verified user for a specific period, allowing you to navigate the application seamlessly until your session expires or you log out. It's a brilliant balance of security and convenience. Even with all these measures, the digital world is a constant tug-of-war between attackers and defenders. Just recently, a GitHub issue title compromised thousands of developer machines, showing how even seemingly innocuous details can be weaponized. Hackers are always trying new ways to break into accounts. They might launch brute force attacks, where software rapidly tries thousands of password combinations. Or they might use credential stuffing, taking leaked username password pairs from one breach and trying them on other sites, hoping users reuse passwords. And of course, there's phishing, where they trick you into giving up your details. But the backend isn't passive, it's constantly fighting back. To counter brute force attacks, backends use rate limiting. This means if you try to log in incorrectly too many times in a short period, the backend might temporarily lock your account or slow down subsequent attempts, making it practically impossible for automated scripts to guess passwords. It's like putting a timeout on someone repeatedly trying the wrong key in a lock. Another critical defense is input validation and sanitization. This prevents malicious code, like SQL injection, from being inserted into login fields. The backend rigorously checks everything you type, making sure it's just plain text and not a dangerous command designed to steal data. Secure coding practices, regular security audits, and continuous monitoring are like the constant patrols around our digital castle, ensuring no weak points are left exposed. The backend is a dynamic fortress, always adapting to new threats. So, the next time you effortlessly log into your favorite app, take a moment to appreciate the unsung hero working tirelessly behind the scenes, the backend. It's far more than just a place to store your data, it's a sophisticated guardian that uses a combination of clever techniques to authenticate your identity and protect your personal information. We've seen how the backend takes your login request, performs a secret handshake using sophisticated hashing algorithms to verify your identity without ever storing your actual password. We then explored how both hashing and encryption work hand in hand, hashing for securing your stored credentials, and encryption for keeping your data safe as it travels across the internet. And finally, we discussed the indispensable role of multi-factor authentication, adding that crucial second layer of defense, turning your simple login into a high-security procedure. The world of backend security is complex and ever-evolving, but understanding these core concepts empowers us to make better choices and appreciate the incredible engineering that keeps our digital lives safe. But what about when you want to give another app permission to access your information, without ever sharing your password? Next, we'll explore how other apps get your permission to access your information without ever asking for your password. Make sure you don't miss it.